Hello, everyone. Welcome back to another exciting chemistry video lessons by Adrenaline, the Bazooka Prophet. Now, a lot of students have sent me a DM asking me to do a video on gravimetric analysis again, even though I've done previous videos on it, but I was asked to do a more concise one. Right. Now, at the end of this particular video on gravimetry, where I'll be going deeper, every student should be able to have an insight. For those of you watching it for the first time, an insight on gravimetry, and at the same time, have a deeper knowledge about it, and also have a shortcut in solving some tricky questions on that gravimetry. I remember my humble self, Adrenaline, the Bazooka Prophet, BSc, MSc, and PhD in chemistry. And I'm your host. Now, in this particular video, I'm going to be taking a question. But before then, we should understand what gravimetry is. Gravimetry is an analytical chemistry, or it's a branch of analytical chemistry, which talks about the measurement of the mass of an analyte. And what is an analyte? An analyte is the substance of interest, or what is being sought after. Now, there are some basic tips you need to understand while trying to carry out a gravimetric analysis. One is that an unknown sample is dissolved in water. When that happens, it is then allowed to react with another substance. When that happens, a precipitate is formed, which is then filtered, weighed, and dried. Right? Meaning, when you filter it, you then dry it, then you weigh. When you then weigh, you then have a chemical reaction or a chemical formula for the precipitate formed, and then you can go on with your calculation. But we should understand that in carrying out gravimetric analysis, the particle size of the precipitate is of interest to us, in the sense that a precipitate must have low solubility. Meaning, if that precipitate is able to dissolve in water, it means that that precipitate is not good to carrying out gravimetric analysis. Right? And on that note, we come to a tip that we have three major types of precipitates. One of it is called the crystalline precipitate. Right? We have a cordy precipitate, and at the same time, we have what we call gelatinous precipitate. But what are their examples? Examples of crystalline precipitate is barium sulfate. Example of cordy precipitate is silver chloride. And lastly, examples of gelatinous precipitate is the hydroxy compounds, which include the iron oxide and iron hydroxide and aluminium hydroxide. So there are a lot of things which we need to understand, and that in performing calculations on gravimetric analysis, right, it obeys some certain laws. One of it is the law of constant or definite proportion, and that your equation must be balanced, and you must know what we call your gravimetric factor, in which the calculations that you are going to be performing depend on, as you will see as we're about to start. I'll be giving you a shortcut in solving questions on that gravimetric analysis. For those of you who are just watching me for the first time, do well to like, subscribe, and share. And also, we have a marathon online summer classes ongoing. It is a banger. It is an atmosphere of aura where students are taking deep into all science and STEM subjects to equip you when school resume. Give not your brain to sleep. If not, it's going to affect you. So let us start with the question. The question says, what is the percentage of iron in a 0.9291 gram sample of an acid soluble ion ore, which yields a ferric oxide, which is also called iron oxide precipitate, weighing 0.6216 gram. Now, there are some tips you need to take note of here. One is, you see, the mass of the sample and the mass of the weighed substance. See, these 2 points I just pointed out, they are very, very important because the formula is what you will need. Now, the formula is percentage salt, which is in this case now, what you are looking at for is what now? Iron, right? Which is not equal to the mass of the weighed substance multiplied by the gravimetric factor multiplied by 100 over the mass of the sample. With this shortcut, with this formula, every question can be addressed. Already from the question, we have the mass of the weighed substance, we have the mass of the sample substance, and the major one now is, how do we determine for the gravimetric factor? This also is very, very what? Simple. So what do we do here? We come here to say you have the weight here to be 0.6216 multiplied by, I will leave space for the gravimetric factor because I will have to determine it. So there is 100 multiplied by, okay, over that of the sample was given to me to be 0.9291. Now I will have to erase the board, right, so I can solve for the gravimetric factor. All right. Now, gravimetric factor is simply equal to, let's say, molar mass or formula mass. So let's say molar mass of the salt substance over molar mass of the weighed substance. Right now, in this case here, now the molar mass of the weighed substance here is what now? Fe2O3. Now the molar mass of what you are sorting out for here, what you are looking at for here, which is this iron here, it will be what now? Fe2. Be very careful. That is where a lot of students might have errors, because they will go ahead to use only iron, not adding this 2 atom of iron to it. Look at it, iron. We are looking at for the iron in this weighed, right? So in this sample what? Substance here. So let us move ahead. So we come here to now say iron is 56. So 56 times 2 is 56 times 2 divided by, iron here is 56 times 2 plus 48 times 3. Oh, sorry, 16 times what? Times 3. So here will give me 112 divided by 160 to give me 0.7. So I then come here to put 0.7. So at the end of the day, when I use my calculator to solve it, I should be having 46.83%, which is also equivalent to what now? Which is also equivalent to 46.80 if you round it off, or 46.83%, as the case may be. So you have to just observe what I've just done here, and that makes the question much more what easier. So know this formula. What you are looking at for, or what is being sorted after, or what is the analyte, is equal to the weight, the mass of the weight substance, which they will always tell you from the question, multiplied by the gravimetric factor, multiplied by 100, which is percentage, over the sample, the mass of the sample, which they will give you also in the question. So we can now then move to another question, even as I erase the board. Even as I erase the board. Okay. Now, the next of the question here is, if the solubility product constant, which is KSP, of silver chloride at 25 degrees Celsius is 1 multiplied by 10 raised to the power of negative or 10, meaning the KSP of this salt is this. Calculate the concentration of silver ion that must be added to initiate precipitation of silver chloride in a 1 times 10 raised to the power of negative 4 molar concentration sodium chloride solution. That is very, very easy. So we go ahead to go deeper to other part of it on how to calculate for it. Very simple. Now you should understand that KSP of silver chloride, remember, silver chloride is the silver ion concentration and chloride ion concentration. I've done a lot of videos on the calculation involving solubility constant, the calculations that are involved in it. So you can do it to check the video up so you can understand why I did it like this. So I come here. Now, my KSP was given to me to be what, right? To be 1 times 10 raised to the power of minus 10 is equal to, I am looking for silver ion concentration. Now, the question now is, from the question, was I given the concentration of chloride ion? The answer is what? Yes, but not direct. But I can get for it from common ion effect. Common ion. Now, the common ion is obtained from sodium chloride, in which if I'm having sodium chloride here, when it ionizes, for example, I'll be having sodium ion plus chloride ion. If for 1 mole, I'm having 1 times 10 raised to the power minus 4 molar concentration of sodium chloride, then for chloride ion only, I should also be having 1 times 10 raised to the power minus 4, right? So I already have my chloride ion here to be 1 times 10 raised to the power minus 4. Now I'm looking for silver ion concentration. So I come here to say silver ion concentration is equal to 1 times 10 raised to the power minus 10 over 1 times 10 raised to the power minus 4. So the final answer becomes 1 times 10 raised to the power of minus 6 molar concentration. And that is how subtle or how easy questions like this are. Understanding chemistry is more preferable than just cramming it. Look at the step-by-step processes I underwent in solving this question. Very easy. Do well to like, share, and subscribe. And if there's more question you want me to address, you can send me a DM. Thank you, and God bless you.